In this last section, what we're going to talk about is just different shapes of distributions. And the first one we'll see is a rectangular distribution where it basically looks like a rectangle. It doesn't have to be a perfect rectangle, but it does look like a rectangle. Another word, if you take a stats class, is this will look like what's called a uniform distribution. And uniform just basically means it looks relatively the same or flat. With the frequency of everything remaining about the same. Again, it doesn't have to be perfect. And J-shaped distributions, it looks kind of like a set of stairs. Again, it does not have to be perfect. It'd be a set of stairs either going up or a set of stairs going down. That's what I always think of when I see the J-shape is I always think of a set of stairs. Bimodal. Bi means two. Mode means highest frequency. So that means by having two modes, you've got two sets of data that have a high frequency. So you have two high peaks. That's what they mean by a bimodal distribution. On this last part, we've got something that's skewed right and skewed left. It's a little backwards of what you would think. Skewed right actually means that all your data here is on the left, and skewed to the left is where all your data is actually mainly on the right. We've already mentioned this last one a little bit, which is what we call a normal distribution, which is what you see a ton of if you actually do take the probability and statistics course. It looks like a bell-shaped curve, and that's called the normal distribution. And it doesn't have to be a perfect bell shape, but it does kind of look like a bell curve, what's called a bell curve, where you have a peak in the middle, and it is roughly symmetric. Remember, symmetric means you have the same picture on both the left and the right side, roughly. Again, it doesn't have to be perfect, but it's kind of like a mirror image on both sides. And like I said, we have the bell curve. And because of this bell curve and it being symmetric, what it means is that the mean, median, and mode for this type of graph, a normal distribution, are all right here in the center, which means that they're actually all equal and right there in the center. Why is the mode there? Well, remember, the mode is the highest frequency, which is going to be where you have your peak. Remember, your median is always in the, median means middle. And if you've got something that is symmetric, it means you've got about the same amount of stuff on the left as you do on the right. So the middle is going to be literally the middle where the peak is. And the mean is going to be your average, which, again, if it's roughly symmetric, it means whatever you have below or that's smaller than the middle, and anything that you have that's above or bigger than the middle should kind of balance each other out equally. And then so when you average everything, you should land in the middle as well, which is why all these three, the mean, median, and mode, should be equal. Specifically, only with a normal distribution should this be happening, that these three are equal. That will not happen in the skewed left, right, or any of the other ones. This distribution is very special, and that's why it gets used a lot. And it does actually, surprisingly enough, fit to a lot of real-world examples. So what we have are two real-life examples that we want to figure out, kind of just by thinking of what it is, as to what kind of shape it would probably provide us. So in part A, the number of people in a household. So you'd have something like this where you have your household, and then you have your frequency. So if your household has, let's say we'd start out with one person, then we'd go up to 2, 3 people, 4 people, 5 people, 6 people. Well, the idea here is you'd have quite a few households with just one person. So let's say if we had talked about 100 people, there'd probably be, let's say, about 20. Same thing with households with 2 and 3. You might have a little bit more households with 2 people, so that might be 30, and then more with 3. But then eventually it would start going down. The higher your number of people in your household, the less frequency there would be, especially as we get into 8 and 9 people. So it'd start trending back down. I'm just making this up, but that's kind of the idea. We'd be looking at a trend where it would kind of grow and get bigger and then come back down, which means most of our data, and it would level out, would be on the left here for the number of people in the household. So my guess is it would look something like this. If most of your data is on the left, it would be skewed to the right. That would be my guess and observation. And on a test, this would be multiple choice, but I'd probably pick something that'd be much more obvious than this, because this to me is a little bit of a guess. Whereas opposed to the next one, if I were to look at the next one, we're talking about a 6-sided die. So we talk about the numbers on a 6-sided die, and then we talk about the frequency of those. Well, the numbers on a 6-sided die are 1, 2, 3, 4, 5, and 6. And the frequency of each one of those numbers on your die is just 1. There's only 1, 1. There's only 1, 2. There's only 1, 3, 1, 4, 1, 5, and 1, 6 on the die. So if you were to graph it, all the frequencies would be level, the same, which means we'd be looking at a rectangular or uniform graph here for this one. So for B, this is a perfect test problem because there's no confusion that this would be a rectangular or uniform distribution. This is a perfect test problem. So we call this rectangular, or in some textbooks they'll call it uniform. And that's it. And again, this would be a much better test question because nobody should be getting a different answer than this.